Hello and welcome back to AIT 1001. Today we're going to cover lesson 4, which is Ohm's Law. And the lesson objectives for this lesson are to calculate the value of voltage, current, and resistance using Ohm's Law. We're going to apply the power formula to determine wattage in a given circuit. We're going to learn how to read a kilowatt meter. This is a type of meter that's on the side of your home that the power companies, utilities come out. They'll actually read those dials on your meter and determine how much how much electricity your home has consumed for a month. And we're also going to determine the amount and cost of electricity used in the home. So basically the textbook's going to go into how to read the meter, and if you can look at your bill and determine the cost your utility is charging you per kilowatt hour, you'll actually be able to predict your power bill before you get it, because you'll be able to read the meter and apply the cost to your actual consumption. And then the textbook also goes into about measuring the resistance of the human body with an ohm meter. So these are the things that the textbook's going to go into. And for the purpose of this presentation, I want to focus on description of voltage, current, resistance. Kind of give you a visual of what voltage, current, resistance does, and then we're going to do some examples using Ohm's Law. We're going to find for some unknown values. So for voltage, current, resistance, I've got a little illustration here. It's a little cartoon illustration, and it's showing it's actually fairly descriptive of what's going on between the relationship between voltage, current, resistance. You have voltage here. A volt is trying to force the amp through the conductor, trying to push it through, and you've got your resistance guy up here, little ohm. He's trying to restrict the flow of current through, and so the voltage is trying to push it through the resistance. So like I said, this is just a little cartoon, but it's actually fairly descriptive of what's going on between the relationship between voltage, current, and resistance. So to give you a little better visual of what's going on, we're going to use a water hose analogy as to describe the difference between voltage, current, and resistance. So to start, I've got a water hose here, and the water hose is what we've learned before with the conductor. Conductor actually allows you to get power from one point to another, and so in this analogy, our water hose will be our conductor. It's actually getting the water from the source to wherever you're going to your load, which could be something out here that you're watering or something like that. Pressure would be equivalent to voltage. So when you open up the valve on the side of your house where your water hose is connected, there's actually pressure there. And that pressure would be the same thing as like what you have with voltage. If I've got a battery sitting there, it's got electrical pressure, we just need to allow a place for that pressure to push current through the flow. So I've got pressure available at the valve, and when I open up that pressure, then it's going to allow my current to flow. So pressure, it would be like the voltage in a circuit. Flow, so when I open up the valve and allow that pressure to push the water through the hose, so now I've got flow, and the flow represents the current in a conductor. So now I've got the pressure pushing the water. The water flow would be like current. And then if I put a kink in the hose right here, if you notice back here, I had full flow through the water hose, so that's like unrestricted flow of the water. If I put a kink in it, and that's like adding resistance to the circuit, and it kind of drops my flow down. It restricts the flow, so the pressure is still there, but it's limiting the amount of flow through that conductor. So that's just kind of a quick visual relationship between voltage, current, and resistance. Like I said, your text goes into it as well, but I wanted to give you a visual of something that you can kind of think about when you're actually interacting with a circuit. So Ohm's Law is a series of formulas that allows you to find for an unknown. So this is something you'll see is pretty common. It's called the Ohm's Law wheel, and it sets you up so that you can, if you know any two variables, whether it be voltage, current, resistance. If you know any of the two, you can find for the third. And that's what this formula wheel is showing you. So if I kind of break it down a little bit, so voltage can be represented by a V or an E, and the unit for voltage is the volt. So, and that's this quarter of the wheel. So if I want to find for voltage and I have my resistance and current, I'd multiply the two together to find voltage. Or if I know power and current, I would use this formula. Or if I know power and resistance, I would use this formula. So any one of these three formulas, based on what information you have, you'll be able to find for voltage. And you'll notice here I say voltage can be represented with a V or an E. V obviously stands for voltage, but E, which you might see in some formulas, and we're going to see that here a little later. E actually stands for electromotive force, which is the what voltage is kind of referred to as sometimes. Current, that's the flow. The unit for the current is the ampere, or amp for short. It's represented with an I, and you think it would be represented with an A, but from Ohm's Law it's represented in I, and it's actually, if you do a search on it, it actually goes back to the French language, and it's translated into intensity. So it's the how intense is the current, or the intensity flow. So, but they use an I for current, so that's one thing you need to remember. So if I'm trying to find for current, if I know voltage and resistance, I would use this formula. If I know power and voltage, I would use this formula. If I know power and resistance, I would use this formula. So I would use any of these three formulas based on what two other values I had to be able to find for current. Resistance, and we've talked a lot about resistance so far in this class. The unit of resistance is the ohm. It's represented with an R, and same thing, it represents this quarter of the wheel. And here's the three formulas that you would use to find resistance, if depending on what values that you had, what two values you had. And finally, power, that is the wattage in a circuit, so the unit is the watt. So based on what two values you know, whether it be voltage, current, resistance, whichever two you had, you would select one of these formulas to determine power for that circuit. So that's just kind of how to use this wheel. And I'm going to get ready to show you an abbreviated thing that shows the three main ones. So the three main components that you normally are working with, wattage is out there, and it's good to know how to calculate wattage using these formulas, or calculating the power. But for the most part, you're going to be doing voltage, current, resistance. That's the three main things that you're going to be working with. And so if you set it up in this fashion here, this basically tells you your three formulas to find for an unknown, depending on which two you know. So first, if I want to find resistance, if I look at the way I have this drawn out, I would take the voltage and divide it by the current, gives me resistance. So that's what this is showing you. The E's on top, the I's on bottom, so you're doing a fraction. So voltage divided by current gives you resistance. And then if I wanted to find current, voltage divided by resistance, so there again, look at that, it's like a fractional line. So E divided by R gives me I. And then if I want to find voltage, then it's I times R, they're side by side, so it's showing that you would actually multiply those two together. So it's just a little quick visual that you may want to keep in mind, that if you ever have to do a calculation, if you can remember this EIR wheel, or drawn like this with the E on top and the I on the bottom, that's a kind of a memorization tool to help you memorize the three main formulas of Ohm's Law. So how are we going to apply this? So I've got a circuit here. This circuit shows I've got 24 volts. That's my power, or my voltage. I have a resistance of 120 ohms. So what's my current in this circuit? So I can apply Ohm's Law to determine what the current is, because I know two of the values, so I should be able to find the third. So I go back here to my wheel. I'm trying to find for I. So I know using this little memory tool, E divided by R gives me I, so that's what I have here. So we're going to plug the values in. E is my voltage, 24 volts. My resistance was 120 ohms. So I divide 24 volts by 120 ohms. That gives me 0.2 amps, or if you want to use our prefix, 200 milliamps. So that's just a simple explanation for finding current if I know voltage and resistance. So let's do another one. So now my voltage is 20 volts, my current is 250 milliamps, and so I want to find for my resistance. So go back to my wheel. I'm trying to find for resistance, so that tells me I need to divide the voltage by the current. So the first thing I need to do, I mentioned this in the last lesson about when we were converting units from one prefix to another. For Ohm's Law to work, you cannot have any prefixes in any of the values that you're using. So whether it's millivolts, k ohms, or meg ohms, or any kind of prefix, you're going to have to convert it to the base unit before you can actually use it in the formula. So 250 milliamps, I need to convert that to the base unit of amps. So if we remember, so from the last lesson, we're going from milli to the base unit. So that tells me I got to move the decimal point 3 places. Now I'm going from from smaller unit to a larger unit. So that tells me I need to move the decimal point to the left. So I need to move my decimal point to the left 3 places to find that my 250 milliamps becomes 0.25 amps. So now I'm ready to plug everything into my Ohm's Law. And like I said, we determined we're finding for R, so E divided by I. I'll plug the values in. 20 volts divided by 0.25 amps, because I have to use the base unit, because that tells me my resistance in that circuit is 80 ohms. Okay, so let's find for voltage now. So now I have a circuit. I've got 20 milliamps, and I've got 1 k ohm resistor. So how much voltage would it take to make 20 milliamps through a 1 k ohm resistor? Go back to my wheel here. I'm trying to find for E, so now I need to multiply I times R. But before I can do that, I have to convert my units. So I've got 20 milliamps, so I need to convert my 20 milliamps to amps, and I need to convert my 1 k ohm to ohms. So milli, if you remember, is 3 places to get it to the base unit. So I'm going from smaller to larger here, so it tells me I need to take 20 milliamps to move my decimal point 3 places to the left. And 1 k ohm to ohm, that means I'm going from a larger to a smaller, so I need to move my decimal point 3 places to the right. So going back here to my formula wheel, I'm finding for E, so that tells me I times R. So I move my decimal point 3 places to the left, comes to be 0.02 amps. I move my decimal point to the right to make 1,000 ohms. I'll do the math. That comes up to be my voltage is equal to 20 volts in that circuit. So that's the 3 main equations you're going to be using for Ohm's Law. Like I said, there's other ones out there that were on that wheel, and sometimes you'll use them based on the information that you have. But these, like I said, these are the main ones that you will likely use. So that's the main thing with Ohm's Law. I mean, if you don't get any other lessons out of this class, Ohm's Law is the basic foundation for anything that you're going to be doing working with electricity. You'll use it in troubleshooting, and it's not like something you're going to learn and you'll never use. Ohm's Law, if you work with electricity, you will use on a regular basis, so you need to make sure you understand this. But as always as before, if you have any questions, please post them in the discussion board, or feel free to email me, call me, or stop by my office. Thank you.